This video will cover section 1.6, other types of equations. Specifically, this video will talk about radical equations. So in the first part of 1.6, we discussed rational equations. And recall that we also briefly mentioned that we've learned how to solve linear, quadratic. Now we've learned rational, and we're going to add radical. Alright, so you have to remember, how do you identify each type? Remember, linear, the variable is x, largest exponent 1. Quadratic, largest exponent is 2. For rational, the variable is in the denominator. Now, radical, the way that we know it's a radical equation is that my variable is under a radical sign. Now, a radical sign can be a square root, it can be a cube root, it can be a fourth root, things such as this. Alright, and so what we have to do is get the variable out from under that radical sign. And once we do that, we may have a linear, we may have quadratic, and we'll solve from there. Alright, so to solve radical equations, we isolate the radical on one side of the equation. So if there are multiple radicals, isolate one of them. Get it by itself on one side. Alright, then we're going to raise each side of the equation to a power equal to the index. Now, the number that sits right here, that is the index. So it's going to tell us what root we're finding. This would be square root, the cube root, the fourth root. Alright, so on and so forth. And we can go as high as we want, but the smallest we'll ever go is 2. Alright, so you're going to raise each side to a power that equals whatever the index will be, 2, 3, 4, 5, 6, and so on. Alright, and this will eliminate the radical sign. So radical signs will undo exponents. Exponents will undo radicals. Alright, then once we eliminate the radical sign, if there are additional radical signs, we keep repeating steps 1 and 2 until all of the radical signs have been eliminated. Then, whatever the resulting equation is, we solve it, and we always want to check our answer in the original equation to verify that it is a solution. Okay, so when I look at example 1, it says the square root of x minus 3 equals 2. Right now, my radical is isolated. It is the only thing on the left side of that equation. So, since it is isolated, I want to raise both sides to a power equal to the index. This is a square root. So I'm going to raise both sides of the equation to a power of 2. When I do that, the square root sign or the radical sign goes away, and I'm left with x minus 3. And then on the right side, I have 2 squared is 4. Alright, this results in a basic linear equation. I add 3 to both sides to find that x equals 7. Alright, now I want to check my answer and verify that it is the solution. So I'm going to come over here, and in my original equation, everywhere there's an x, I'm going to put a 7. So I'll have 7 minus 3 equals 2. Alright, so that'll be the square root of 4 equals 2. The square root of 4 is 2, which does equal 2, so I know my answer is correct. You can also use your calculator and do the same thing. Alright, for number 2, x minus the square root of 4x plus 12. In this equation, the radical is not isolated. On the side with it is an x. So what I need to do is move either the x or the radical. Now, because I like everything to stay positive, if possible, I'm going to take the radical sign and move it over here where the 0 is at. But if you move the x, there's nothing wrong with that. Okay, either one, as long as you get the radical sign isolated. So I'm going to add the square root of 4x plus 12 to both sides and get the radical on the right side by itself. So it doesn't matter which side you get it on as long as you isolate it. Alright, so now that my radical is isolated, I'm going to square both sides. And the reason I'm squaring it is because I want to raise it to a power equal to the index. When I do that, it removes the radical sign or cancels it out. Alright, so I'll be left with x squared equals 4x plus 12. Alright, so now that the radical sign has been removed, when I look at the equation, I can see that it is a quadratic equation. That x squared tells me that the largest exponent is a 2. Since it's quadratic, I want to set it equal to 0 before I try to solve it. So you can move the x squared over with the 4x plus 12 is fine, but I like to keep my leading term, the x squared, positive. Just if I need to factor, it's much easier if it's positive. So I'm going to move the 4x and the 12 over here with the x squared. So I'm going to subtract it from both sides. So now on the right side, I have x squared minus 4x minus 12 equals 0. And at this point, I can either factor it, quadratic formula, or complete the square. If it will factor, that is the easiest. Alright, so I'm looking for what multiplies to give me a negative 12 and will add to give me a negative 4. Alright, and I believe that will be negative 6 and positive 2. Then when I take and set those equal to 0, I'll find that x equals 6 and that x equals negative 2. Now I want to take both of these and substitute them back into the original equation and verify that they both work. And now you always want to do that, especially with radicals and rationals. Alright, so in my original equation, I'm going to substitute 6 and verify that I get 0 on the left. Alright, so then 4 times 6 is 24 plus 12. Give me 36. And then the square root of 36 is 6. And 6 minus 6 is 0. Alright, and I can see that 0 and 0 are the same, so I know that 6 is a solution. And I want to try the same thing with negative 2. So we'll fill in negative 2 everywhere there's an x. Alright, we'll have negative 2 minus negative 8 plus 12. Make sure you can see what I'm writing here. Alright, then that'll be negative 2 minus the square root of 4. Alright, then negative 2 minus 2. Negative 2 minus 2 is negative 4. Alright, and negative 4 does not equal 0. Alright, so therefore negative 2 is not a solution. So you have to check both of them. Alright, and if one doesn't work, make sure you tell me which one does work and which one doesn't work by some indication. Okay, you can just cross it out, circle it, some indication. Alright, now you can also use your calculator, alright, to do the same thing I did here, and this is what's happening when you do use your calculator. It's just substituting in place of x. So you can either do it on your paper or use the calculator. Either way is fine with me. What I'm looking for is this right here. Alright, for the last one, we have the square root of 2x minus 1 plus 5 equals 8. Alright, so at this time, the radical is not isolated. It has a plus 5 on the same side with it. So I'm going to remove that 5. Alright, when I do that, I'm left with the square root of 2x minus 1 equals 3. Alright, so now I want to remove this radical sign, so I'm going to square both sides. That'll leave me 2x minus 1 equals 9. Alright, when I look at it, I see that this is a linear equation, so I'm going to isolate my variable term and constant term, and then solve for x. When I do that, alright, I find that x equals 5. Alright, now I want to check my answer, so I'm going to come back to my original equation. Everywhere there's an x, I'm going to put a 5. Alright, that'll be 10 minus 1 that'll be 9. The square root of 9 is 3. Alright, and then 3 plus 5 is 8, and since 8 does equal 8, I know that x equal 5 is a solution. One thing I do want to mention, alright, is make sure that when you're working out these problems that you are writing down this right here. Alright, that you are squaring both sides, that you write that down for all the problems that you practice with. When it comes test time, one of the errors that I see the most is that people will just write x minus 3 equals 2. So they'll drop the radical sign, but they won't square the right side. So while you're practicing these problems for homework or in class, wherever, make sure you write down the squared part. Don't leave that part out because when it comes to test time, like I said, the common error is to drop the radical sign and forget to square the other side.